Hey, welcome back to this YouTube channel. And today we are going to study reaction mechanisms. Under reaction mechanisms, we look at how to deduce rate laws from given reaction mechanisms. Okay, and then in this video, we'll only consider for bimolecular reactions. Okay, now a bimolecular reaction is an elementary step involving collision of two reactant molecules. Okay, now let's consider an example of a bimolecular reaction, and then we'll consider a mechanism of a bimolecular reaction. Let's say that you are given in step 1. In step 1 you are told NO gas plus bromine gas, those two react to produce these products, and then these are in the gaseous state. Okay, and then you are told that this is the first step, and then in step 2 you are told that that intermediate that is formed from the first step reacts with nitrogen 2 oxide gas, and then to produce this product. And then you are told that this is the slow step. Okay. Now, from this reaction, before we deduce the rate law of this reaction, the first thing that we are going to do is to write the net equation for this reaction. The net equation will be nitrogen 2 oxide plus bromine gas. Those two react to give this product. Okay. Okay. We don't include the intermediates. We don't include the intermediate in the net equation. Okay. Now, let's look. When writing rate laws, when we want to determine rate law of a bimolecular reaction, and then you are given a reaction mechanism, the slowest step of that reaction mechanism determines the rate law. Okay. Now the slowest step is the rate determining step. Okay. Now, and then we have step 2 as the slowest step, the rate determining step. Now let's write the rate law of the slow step. Rate will be equal to K2 NOBR 2 NO. Okay, that is the rate law. That's the rate of the slow step. Okay. Now, from the rate of the slow step, you notice that there is an intermediate there. Okay. Now, this intermediate, when writing the rate law of the slow step, the intermediate is unnecessary. Okay, because intermediates are unstable molecules. They can easily dissociate, and when they dissociate, they come back to the constituent components which make up that compound, the intermediate. Okay, that's why when writing the rate law, this intermediate should not be included in the rate law. Okay, now if this intermediate is unnecessary, then how are we going to write this rate law? Let's see how we are going to write this rate law. Now, when dissociation takes place because of instability of this intermediate, then we'll have the rate of forward reaction. The rate of forward reaction to be equal to the rate of the reverse reaction. Okay, and then when we write that one down, we'll have K1 of NO BR2 to be equal to K in the reverse direction of NO BR2. Okay. Now this is the rate forward reaction, and then this is the rate of the reverse direction. Okay, now when we solve for that intermediate, because that is what we want to solve. Now solving for NO BR2, then we'll have this. This is what we'll have. We'll have NO BR2 to be equal to K1 over, and then of NO BR2. Okay. Now when we substitute the relationship into the rate law for the rate determining step, after writing this from this equation, after solving for this intermediate from this equation, okay, the next thing we do, this is the intermediate. Now we put this one into the rate law, the initial rate law, okay, and then when we substitute the relationship into the rate law for the rate determining step, then we'll have K2 into K1 over K in the reverse direction of NO BR2 of NO, and then that one should be equal to K of NO squared BR2. Okay, because we have two NOs, then we'll write NO squared, and then I place this constant as a single constant, K now. Okay, and then this will be the rate law of that reaction. Now this is the rate. Rate will be equal to this. Okay, now that's how we write the reaction mechanism of a bimolecular reaction. We consider mostly the slowest step of this reaction. After looking at the slowest step, we write the reaction mechanism of the slowest step. Okay, I mean the rate of the slowest step. After writing the rate of the slowest step, then if there are intermediates in that rate, then we solve for those intermediates in that rate. After solving for intermediates, then we'll have our rate law. Okay, thanks for watching. Have a good day. And if you're new to this channel, click the subscribe button, and then if you like this video, you can leave a like. Okay, have a good day.